right, so we're going to pick up with the linear equation application. So we're going to do a few word problems with what we're doing. We did a few word problems in the first unit with solving equations and things like that. So we're going to do a few word problems in this unit. We're going to kind of do that every unit that we go through. It's going to have some kind of word problem component to it. So we're going to try to help you decode how to work word problems. I know that's something that's kind of been avoided a little bit, or it's hard to do. It's kind of tough. And my saying is, life's a word problem. Just figure it out, okay? So we got to figure out, lifetime situations. Not that setting up an equation is something that you always have to do when you're solving your everyday problems when you get grown up. Not always the best thing in the world, but having some sort of application of what we're doing in class is always a helpful thing. It helps me understand it better. So let's pick up there with number 7, and it asks us to write a slope-intercept form equation for the situation there. So A part says write an equation to represent the cab fare and define your variables. Okay, the cab fare or cab ride costs $4 plus $1.75 per mile driven. So when we're thinking slope-intercept form, we know that's y equals mx plus b, right? Any letter will do, but b is the one we normally use there. So we're going to look for writing an equation that looks something like that. So slope and y-intercept are the two numbers that we need from our word problem. So this is really a basic word problem, just one sentence deal. So write an equation that represents the cab fare and define your variables. So if we're looking for a slope-intercept form, we got to have a y and an x, right? Technically, we can use whatever letters we want to, but because we're thinking slope-intercept form, we're going to use y and x as our variables because those are the ones we're used to. If the cab ride costs, and then it starts saying something, to me that states that the thing that's equal to everything else is the cab ride. So y in my book is going to be the cab ride. The total cost of the ride is basically what it means by cab ride, is the total cost. And what would x represent with this? Say it again, man. Number of miles, absolutely. I'm just going to write miles there. Save myself a little bit of room. So how many miles we drive, that's x. And then the cab ride, the total cost is going to be y. All right. Now, looking at those two numbers, $4 plus $1.75 per mile driven, which one of those would be the slope and why? Why would you say 4 is the slope? Give me a good, valid reason for that. Bless you, bless you. What happens with the slope in a slope-intercept form equation? What does the slope do in the y equals mx plus b? What does the y-intercept do? Think about how we graphed things that were in slope-intercept form. What did we do first? Find y-intercept. So that's your starting spot, right? So with this cab ride, what's our starting spot? As soon as we sit down and shut the door in the cab, we owe them some money. We owe them $4, right? Just for getting in, whether we go from here to Jack's up here in town, or we get in the car and we ride all the way to Memphis. Okay, either way, we owe them $4 at the beginning, right? So I think $4 is going to be our y-intercept here because we owe them that. It says it costs $4 plus some other stuff. Okay, so the $4 I think should be our y-intercept. So I'm gonna write my equation y equals. I'm gonna put something with that x, and I'm gonna put plus the $4. Here's the key word that you're looking for: per. Anytime you see the word per, that's got to make you think slope. That whatever number that goes with that per is going to be my slope. So $1.75 is going to be my slope for that problem. So I should have y equals 1.75x plus 4 as the slope-intercept form of the equation for that particular situation. So anytime you see per or for every, Those are keys to knowing that number that's associated with that is the slope. B part says Clay's destination is 17 miles away. He has $30. Can he pay for his ride? Is basically what they're asking. So if his destination is 17 miles away, where does the 17 go in my equation? It's the x. That's how many miles. So that's going to be y is equal to $1.75 times 17 plus 4. So on my calculator, I'm just doing $1.75 times 17 and then plus 4. And the cost of the ride that he needs to take is $33.75. Does he have enough to pay for that ride? No, he ain't gonna make it. The cab driver asked him how much money you got. He doesn't have more than $30. He's gonna have to get out and walk the rest of the way. Either that or that cab driver is gonna report him to the police, and they're going to come after him for $3.75. Believe it or not, that's what happens. All right, let's look at number 8. Flip your page there. Another word problem situation, and it says the Joneses are purchasing a new home. The closing costs are $249 plus 3% of the purchase price for the home. Again, we're going to, in A part, write an equation for the situation and define our variable for the total closing cost of the home. Okay, so I'm going to use y and x again because that's what we're used to. Y normally is going to be like your total cost. In most situations, what we're dealing with, total, if you're looking at slope-intercept form of equation, the y is going to be your total cost or your the total amount there. So x is going to be what in this situation? What's the one thing we don't know? We don't know the purchase price, so that's what x is going to be. All right, so let's write an equation in slope-intercept form for that. So y equals something x, and then plus. Say it again, Mike. How come? All right, that's how much we know we're going to have to pay, no matter how much the house costs, whether it's a $50,000 home or it's over in Pickwick and it's a $2.7 million home over there on the lake. Have y'all ever driven by those? Impressive or depressing, one of the two. I'm not sure which out of it will ever happen. So what would our slope be here then? So that's the part that's missing. 3%. So how do we represent 3%? 3 over 100, or we can turn it into a decimal since we're talking about dollars and cents. I'm okay with decimals there. So 3 over 100 is a great way. Or what's that as a decimal? 0.03. So whatever a percent is, move the decimal place twice, and that's how you get the 0.03 or 3 over 100. Both of those work. Same equation there. All right. Now, B part says, okay, let's use that equation that you made. It says purchase price of the home is $195,000. So a pretty fair home there. That's a pretty good sized place, probably. And the seller sellers offered $5,000 in closing cost assistance. Will this cover all of their closing costs? If not, how much will the Joneses need to pay out of their pockets? This is pretty commonplace. I don't know if does anybody's moms, dads, guardians, or whatever, brothers, sisters, do real estate. This is pretty commonplace to offer closing cost assistance in selling a home, because closing cost is just extra money that they're making you pay to buy the house. It's weird way of doing things, but it's what they do. It's closing costs. So they've offered $5,000 in closing cost assistance for a $195,000 home. So we're going to put that 195 where? In the place of X, because that X is the purchase price of the home. So we need to find out what 3% of 195,000 is, and add that to the $249 that we're getting, and we're going to find out what the total closing cost is. So this is kind of like the cab fare problem. You know, we want to know, is 5,000 enough to buy this, to cover all of our extra costs here? So I'm going to do 3% of 195,000 plus $249. $6,099 is how much the closing cost for this home is. And they offered 5,000 in assistance. Does that cover it all? No. So I'm going to take 5,000 off of that. $1,099 out of pocket. So they agree on a purchase price. As you get older, and you guys are be out of school here, not going to seem like in just a day or two, you'll be out of school and you'll be starting life. If you're going to buy a home, this is kind of, you agree on a selling price or a buying price with the realtor and the owners, and then they start tacking on this extra stuff. Same thing if you go buy a car. You guys are probably closer to buying a car than you are a home. You go to a dealership and buy a car, they're going to say, okay, here's what you're paying for the car, and it'll be $25,000, whatever. It's a new car, $10,000, whatever it is, depending on what you're buying. And then they're going to say, okay, then we got to pay a doc fee, which, what is that? I mean, it's money for paperwork. And then they say, then you got to pay a stock fee and all these other fees that they add on top of that. So buying a home's the same way. And they figure up these things with an equation is how they do that. And it basically just means it costs you money. That's all it really means. So I'll walk into the dealership, unless you can pay cash total for it, you're going to pay those fees. They're not going to let you walk out if you say, oh, I'm not paying those fees. I'm going to pay all of it right now. They're probably not going to let you walk out without buying that car, but they're not going to charge you all those. So number 9 takes a 22.5 ounce candle and burns it at a rate of 1 ounce every 5 hours. Write an equation to represent the amount of candle left. Okay, so this one's a little different because it says it wants to know the amount of candle left. So Y is going to be the amount left. What's X going to be here? Not 5 hours, because it's probably going to burn that candle more than 5 hours. You light it when you get home from school, and then you burn it till you get ready to go to bed or something. That's usually kind of what folks do. Well, it's not going to be a number. What's X going to represent? It's going to represent the number of hours that we light it. And today we may go home and light it as soon as we get home. 3:30, we're home from school. We light that nice smelling candle when we get in the house. And then let's say 6 o'clock, we got to meet somebody at town for supper or something like that. We're not going to leave that candle burning, or I hope you don't when you leave the house. So you're going to blow it out. So we only burned it for 2.5 hours today. But tomorrow we get home from school and we're not going anywhere. I'm not leaving this house. I'm going to get my pajamas on and just watch Netflix for the next 3 days. And so we light that candle. We just leave it burning until bedtime. So tomorrow we may burn it for 7 hours straight. So we're not burning it exactly 5 hours every time. So the number of hours that we burn it is what X is going to represent. Now here's the tricky part of this one. What was the original amount of candle? So our starting spot is a brand new candle at 22.5 ounces. Okay. Now, what does this word rate make you think of? Okay. Percentage. Think about it in terms of linear equations and the slope-intercept form that we're dealing with. Well, part of it was also had the name rate of change. Slope and rate go together. So this one, it says the rate of 1 ounce every 5 hours. So 1 ounce every 5 hours would be 1/5. But here's the thing. Is that candle getting bigger or smaller? So what kind of 1/5 is it going to be? Negative, because we're reducing our candle by 1 ounce every 5 hours. So the negative 1/5 there. So you could do it as 1/5. If you wanted to write that as a decimal, that's fine too. What would be the decimal for 1/5? 0.2. Yeah. Either of those would be absolutely fine. Because there's a decimal in 22.5, I'm just changing it to a decimal. And it's a terminating decimal. So that makes it a little easier. If it said 1 ounce every 3 hours, I'd probably leave that as a fraction because you'd have to end up rounding that at some point. So if I leave it as a fraction, it'd probably be better. Then it says, how many hours will the candle last? Oh, how do we figure that out? How much is left when the candle's done? Theoretically, we all. How much of the candle's left when it's finished? None. Mathematically, none is what number? 0. So the amount left is 0. So we'd set up this equation. Now we know that in reality, when the candle is down at the bottom, it doesn't burn up all of that wax, right? There's a little bit left at the bottom. But in theory, there's none of it left, so it's at 0. So we solve this equation. I'm going to subtract 22.5. Negative 22.5 divided by negative 0.2. 22.5 divided by 0.2. 112.5 hours. I'm writing hours there because we're in the context of a word problem. You need to tell what that number means. Is that 112.5 minutes or hours or seconds or whatever? So 112.5 hours. That's quite a long time. That's a lot of candle burning there. Good deal. All right. Let's look at 10 and 11. Notice that the heading there changed. It said linear equations or linear equation applications in standard form. So what do we know about standard form? Y and X are on both same sides. So AX plus BY equals C. Madison brought up something. She was doing some Khan Academy, she said this morning, and the assignment that talks about standard form, it didn't follow all of the rules for standard form. They didn't require A to be positive. So be careful of that when you're doing the Khan Academy. When you get to the one that's about standard form of equations, A doesn't necessarily on Khan Academy doesn't have to be negative or doesn't have to be positive. It could be negative. So that's one thing she noticed with that, and just made the adjustment there. So keep that in mind when you get to those Khan Academies, that the A in their rules doesn't have to be positive. Miss George and I were actually talking about that earlier today, about standard form, and how we've both seen other textbooks that require A to be positive, and then seen some that allowed A to be negative, but all of them were of the same rule that you couldn't have a greatest common factor bigger than 1, so everybody had to be, simplified, and no fractions were common rules that we saw with that. So be careful of that with Khan Academy, and I'll try to be lenient with you on stuff that we do, quizzes and stuff. All right, number 10 says Josh bought 3 bags of potting soil and 10 bags of mulch from the Home Depot. Okay, so write an equation representing the total cost and define your variables. So when you're looking at standard form, you've got your two variables should be representing two different things. Where when we were doing with slope-intercept form, our y ended up being like the total of things. So with standard form equations, you look at the problem and you'll see two different objects. So here we got potting soil and mulch. Those are two different objects. So our variables are going to be those two objects. So potting soil and mulch are our X and Y. And the total is just going to be, we're going to put a C there in that place. So for us, 3 bags of potting soil plus 10 bags of mulch equals some total. We don't know what that total is until we get to B part. And let's say Josh went over there and to Lowe's and bought these, 3 bags of potting soil, 10 bags of mulch, or to Home Depot. You'd have to go to Jackson to do that. I think that's the closest one. And he spent $40.91. We're assuming that the cost includes tax on the cost per bag. So, and it says mulch cost $2.75 per bag. How much does a bag of potting soil cost? So what we're going to do in our equation is X is the potting soil. That's what we're looking for. And what are we going to put in the place of Y? $2.75, because that's how much they said the mulch was per bag. And then in the place of the C over there, we're going to put the $40.91, the total that they said that it made. And then we're going to work that out. So this is going to be $27.50. Yeah, I got to subtract that from $40.91. So $40.91, whoops, 40.91 minus $27.50. $13.41. Divide that by 3. Expensive potting soil. $4.47. Works out nice. Now, when we're rounding, if you ended up having to round that, how many places do you round? Because the instructions are not going to tell you. Why to the nearest 100? What are we dealing with here? Money, dollars and cents. We were round to the nearest cent, which is the nearest 100. So in the context of the problem, you got to keep in mind, hey, if we're dealing with money, you'll round to the nearest cent unless they tell you round to the nearest whole dollar or something. They'll tell you something different. But if it's a money problem, think, okay, nearest cent is what I've got to go for there. Let's look at number 11 there. Kaylee has a collection of quarters and nickels. And we want to write an equation to represent the total value of the coins. And so I'm going to say X is quarters, Y is nickels, and total value of the coins. So how much is a quarter worth? 25 cents, so 0.25 X. How much is a nickel worth? 0.05 cents equals how much they're worth. C, we don't know that. Okay, so B part says the total value of the coins is $5.50, and Kaylee counted the quarters up, and she had 17 of them. How many nickels did she have? So plug in the stuff where you know. So 0.25 times 17 plus 0.05 times y equals 550. Work it out. 17.25. And then 550 minus 4 1/4. $1.25. And then divide that by 0.05. 25 nickels. I'm just writing nickels out there beside it. We know what that goes with. We kind of get the idea of setting up standard form equations out of that. That x and y are going to be the things you have, the objects, and then the coefficient, the a and the b in front of those are going to be the number of those you have or the amount they're worth, or how much they cost per bag or something like that. So I think you could do number 12 if you needed to. It's very similar to number 11. So let's flip over to the next page and talk about scatter plots and correlation and no correlation, all that stuff. So scatter plots are just plotting points on a coordinate plane. And you have a relationship between two variables, and what that creates is a correlation. So a correlation is the relationship between the two variables. Right now, we're in linear part of math, talking about things that are linear. In a week or so, we're going to get into the quadratic side of things, and we'll start talking about a quadratic relationship. So you'll start seeing that parabola shape happening that you learned in algebra. In algebra 1. So, and then later on, we'll get into polynomials that are bigger, and we'll start seeing like a lot more curves happen. But the relationship we're dealing with are linear relationships. And if there's a positive correlation, what that normally means is that the coordinate plane, when you plot your data points, and I'm just going to draw mostly first quadrant here, your data points, they may not be perfectly in line, but they kind of follow a trend that looks like a positive slope. That's a positive correlation. Is that the points that you have that you plot on a coordinate plane, they kind of follow a positive slope line. The negative correlation, very same idea. When you plot the points, they don't fall perfectly in line, but they do kind of follow the trend of a negative sloped line. That's a negative correlation. No correlation means they don't follow any kind of trend. They're just kind of random, just all over the place. They don't follow a certain path. Okay, so positive correlation, positive slope. Negative correlation, negative slope. No correlation, they don't follow any kind of line out of that idea. Okay, so line of best fit is what we're going to end up finding, and trying to predict some things using that. We're going to use the graphing calculator to help us find the line of best fit. We're going to do an example here with out the calculator, and then we're going to do it with the calculator. I'm going to show you the difference in the two lines. Okay, so right below that, you'll see that example, and it's got the table on the left shows the relationship between the depth D of the lake in feet and the water temperature T in degrees Fahrenheit. And it wants us to make a scatter plot. And they've got us one on here that we're going to draw or plot these points on and look at the correlation. And then I'm going to show you how to do that with the calculator so that you don't have to draw out a coordinate plane and look, so you can see the trend that's happening with the calculator. So let's first plot these points by hand first, and then we'll use some stuff to get there. So looking at this, the y-axis the numbers are all in the 70s and 80s, right? So it's not, I don't think we need to start at 0 there, right? So what I'm going to do is I'm going to make a note here. I'm going to put a little squiggle right there through that. And then I'm going to start counting from a different number. I'm going to start counting at 75. So that first mark there is going to be 75, 76, 77, 78, 79, and that's going to be 80. 1, 2, 3, 4, 5. And that's going to be 85. So I'm just changing the scale or the y-axis there so that I can go a little bit smaller graph out of that. The good thing when we do this with the calculator, it'll zoom to the right spot for you. It's really cool. All right, so the x-axis has numbers from 0 all the way up to 15. And when I look at how many blocks I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got 16 blocks there. So I don't need to change anything about the x out of that. I'm just going to use the x just like it is. So the first, the origin there is 0, 0. So I'm going to plot these points based on that. So 0, 85, that'll be that dot right there. 4, 82. 1, 2, 3, 4, 5. There's 80. 82 would be right there. 7, 81. 6, 7. And then 10, 79. So 1, 2, 3, 4, 5, 6, 9, 10. And then 79. There's 80. There's 79. And then 12, 77. 12, 78, 77. And then 15, 76. Right there. What kind of correlation do we believe that has? A negative correlation, okay? So we see that negative correlation. It's linear. It looks kind of like a straight line, doesn't it? Not perfect, but it looks like a line. So here's what we're going to do next. B part says use two ordered pairs to write the equation of a line of best fit. So that's doing it by hand, manually finding a line of best fit. And so what you do is you take your straight edge and you try to pick 2 points that looks like the line gets as close to all of them as possible. So when I do that, if I pick this first point and maybe the next to last point, that gets pretty close to a lot of them. The first one and the last one gets pretty close to a lot of them. I mean, it's kind of a guessing game about which one you think's the closest. Okay, so you pick 2 ordered pairs. I'm going to pick the second one and the next to the last one. So this one and this one. So the second one was 482. So that's one I'm using. And then the 1277. Those are the 2 that I'm going to write my equation with because I think that fits best. Okay, so I'm gonna what do I need to do to write the equation from 2 ordered pairs? Yeah, I got to find the slope first, right? So 82 minus 77 over 4 minus 12. The 5 over negative 8. So a negative slope, that makes sense, right? See how negative correlation, negative slope should be there. All right, so I'm going to go with point slope form here. Y minus 82 equals negative 5 over 8, x minus 4. So I'm just doing point slope form like we did yesterday, and I'm going to finish with slope intercept form is what I'm going to get at the end. All right, and then work that out.
Blake Ritter reports to the office.
So negative 5 over 8 times 4. That's going to be a positive 2.5. So negative 5/8 x plus 2.5 or 3 over 2 I'm going to do decimal here, 2.5. I'm going to change -5/8 to a decimal too. Because we're going to compare this to what the calculator does, and it's going to be in a decimal too. 0.625. And then add 82 to that, so y is equal to -0.625x plus 84.5. That's what I think is the equation of best fit by eyeballing it. Okay. Then it says predict the temperature of the lake at 25 feet. 25 feet is the depth. So what we would then do is take our equation, 625, and put 25 in the place of x. Negative 0.625 times 25 plus 84.5. 68.875. That's what we found using that equation. Okay. So that's doing it by hand. We're going to do that same problem. I want to show you how to use the graphing calculator to do that. So you need to pay close attention. If you'll look down there at the bottom of that page, it's got the steps written out that I'm going to take you through. But if you'll just follow along with me, that'll get us all kind of at the same place at the same time. Okay. So everybody grab your graphing calculator, turn it on, and then everybody hit the stat button, which is right beside the circle there, the arrows, but it says stat. Hit that, and then everyone hit number 5 and hit enter. And you should see this up on your screen. Okay, what that does is just resets everybody's list, so in case something was wrong with yours, it reset them. Okay, now you don't have to do that usually ever again. Okay, so that just gets everybody on the same page. Now, here's following the steps. Look there at enter your data. That little column says hit the stat button. So stat, and then it says edit, and it says hit enter. So I'm going to hit enter, and it's going to take me to this. Now, some of you may have some data that's in your list. You may have numbers that are already there. Raise your hand if you do. Okay, good. I'm glad you do, because I'm going to show you how to clear out a list. So let's say I had some random numbers in this list. I'm going to put some in there just so I've got some. So when I went to edit, I had these numbers in that list. What I need to do is press the up arrow until the name of the list, L1, is highlighted till it's darkened in. And then I want to hit clear, which clear is right above the little housetop symbol, right below the circle of arrows. Hit clear, and then hit enter, and it will empty that list out. Okay. If you got something in list 2, go over there, press the up arrow, hit clear, hit enter, and get rid of it. So you want list 1 and 2 to be empty right now. It doesn't matter if there's anything in the other list. You got stuff in list 3 and 4, don't worry about it. We're not going to use those anymore. Okay. So list 1 and 2 need to be empty. Come on. So everybody there. Don't want to run off and leave anybody, because it can get confusing if you get a step or 2 behind. Okay, so in L1, we're going to enter the X values. That's what it says for the next step. So the X values are the depths. We're going to enter them in the order that the table has them. Okay, so 0, and then hit enter. 4, hit enter. 7, enter. 10, enter. 12, enter. And 15, enter. And then you're going to enter the Y values in list 2. And again, you need to put them in the order that they are on the table, because we're putting the ordered pairs in here is what we're doing. 0, 85. 4 goes with 82. 7 goes with 81. 10 goes with 79. 12 goes with 77, and 15 goes with 76. Okay. Everybody got those in there. Okay, now I want to show you how to get your calculator to do the scatter plot. Okay, so we're not moving on to the next column on the instructions yet. We're doing a scatter plot, so this is not on there. So the scatter plot is the graph that puts the dots on there, so you can look at that. Okay, so to do that, what you need to do is hit second, so the little blue button up there in the corner, and then the top left button that Y equals. Hit that button, and it should take you to the page that looks something like this. It says stat plots at the top. Everybody there? All right. On number 1, just hit enter. And I'm going to turn mine on. Okay. Mine is off at the moment, so I'm going to make sure the on is darkened in and the off is not darkened in. Okay. Right underneath that, it says type. There's several things the calculator can do with the graphing function of it. The first type is the one we want. So that's the scatter plot. This one is a line graph that it plots the points and then connects them with a line. The next one is a histogram, so that's useful kind of in statistics and science classes too. We just use those there. And then the next two are box and whisker plots. Y'all remember doing those way back? They're no fun. So those are what those are. And this is a step function you don't use very much till you get to like pre-cal or something like that. So make sure the first type is highlighted. Make sure it says XList is L1. Does anybody's not say L1? Okay. Make sure your Y list says L2. Does anybody's not say L2? Okay. The next one, the mark, it's just what do you want the dot to look like? I usually pick the first one because it's pretty easy to see. I never pick the last one because I'm old and I can't see it because it's just barely a little dot and it's hard to see. It doesn't really matter which one of those pictures you pick. I'm picking the first one because it's easy to see. And then if you've got a color version, you get to pick what color it does it in. If you got the black and white version, it's going to show you the same picture. It's just going to be in black and white. All right. Now, once you've done that, we're going to hit graph. And you should see pretty much nothing. And then we're going to hit zoom, which is right in the middle of the top row. And then we're going to scroll down to number 9. Oops. Zoom. And number 9 is zoom stat. So that's what we want. When you hit that, and it should give you this picture. Zoom stat. Raise your hand. You're not there. All right, hit zoom, and then number 9. And get the anybody else not got that picture? There. All right. You don't. It's right here. Second line, please. And again. Now hit right. Now hit zoom. All right. Now, that looks like the same picture we drew by hand, right? Exactly the same thing. Okay, so the calculator can give you that. You can look at that, see that's a negative correlation. Really easy to see. Now, here's what we want to do. We want to follow those instructions to find the line of best fit. And what the calculator does is what's called a least squares regression. And it puts a line in between all these points and then finds the smallest squares that measure between the line and the points. It's really a lot of complicated algorithm that finds this line, but it's going to find the line that fits it best. It gets the closest to all of the points. We had to just pick 2 and kind of guess at it. It's going to do a little bit better job. So to do that, we're going to just hit the stat button. We're going to go over to the right to the calc menu there. So stat and the right button. And then you're hitting linear regression, which is number 4. And it should say X list should be list 1. Y list should be list 2. Does anybody's not have those two in X and Y lists? All right. If yours doesn't have that in the X list, to get L1, hit second, number 1. To change the Y list to list 2, hit second, number 2. And then you got them. Anybody else? Is that anything else? All right. Now, frequency list should be blank. So if you've got something there, hit the delete button and it'll get rid of that. So you want frequency list blank. Store regression equation, we're just going to write it down. We're not going to store it anywhere. We're just going to write it down. And then the last line is calculate, and that's the go to it button. All right. So that's how you make it work. So we're going to hit enter on that. And it tells us the exact line that fits that data the best. You may have like an R or an R squared underneath that, and that's okay. You don't really have to have that at this point. I don't have it turned on my calculator at the moment. If you have it, great. If you don't, it doesn't matter. Okay, you don't need it. Okay. Now, the slope is the A, the y-intercept is the B. So our slope here is negative 0.606 repeating. So I'm going to round that to 3 decimal places. So with the calculator for our problem, it got y equals negative 0.607x plus 84.853. So 84.8 would 5 would round up to 84.9. That's what the calculator found. That's pretty doggone close to what we found by doing it by hand, but it's not exactly the same. That line is a better fitting line than what we did, even though what we did was really, really close. So without the calculator, you can get kind of close, but you can't get it exactly the same as the graphing calculator will. Okay, so being able to find that equation of best fit is what we're after here. Go ahead and flip over to the back there, and let's do another problem here. Let's look at number 1 there. Number 1 says table below has people and suitcases on 8 airplanes. Find the regression equation. So it doesn't even want us to do a scatter plot. It just says find the regression equation. So we don't have to go through the trouble doing a scatter plot. We're just going to put in the data and do the linear regression with that calc menu thing. So when they give you a table and it's horizontal like this, X is on top, Y is on the bottom, always. That's the way it always is. ACT, end of course, it doesn't matter. That's the way it goes. If it's a vertical table, X is on the left, Y is on the right. It's horizontal, X is on top, Y is on the bottom. Okay. So we'll put this data into my calculator. So I'm going to go to Stat, Edit, and I'm going to clear out list 1. Clear, enter. I'm going to clear out list 2. Clear, enter. Put those X values in there. And put those Y values in there. Once you got those in there, hit Stat, go over to Calc, Option 4, and you shouldn't have to do anything there. Just go down to Calculate and hit Enter. And it's going to give you the slope and the y-intercept. Let's round to 3 decimal places. I think that's a fair amount on both numbers, and that keeps us honest there. So that'd be y equals 1.834 x plus or minus 16.498. And then it says predict the number of suitcases on a plane with 500 people on it. How do you do that? Plug 500 in where? X or Y? X, because X is, in our table, X is the number of people, right? Because P is for people. So X is the number of people, so we're going to plug in. I'm going to do that with the calculator. 1.834 minus 500 minus 16.498. 900.5 suitcases. I'm going to round that up to 901 suitcases. Why did I round it up? Yeah, and I can't have half a suitcase, right? Not before I start the flight. Somebody's flown before, afterwards it may be different. Working baggage aren't always the nicest to your bags. They can rough them up pretty good. So I'm gonna round up to the next. If it even, I would have even rounded up to 901 if it had been 900.2, because you can't have 0.2 of a suitcase. And if I'm planning ahead, if I'm the airline and I'm trying to plan for storage of baggage, wouldn't I rather have extra room as opposed to not enough? So that's why I'm going to round up if it's over 900. So just in context of the word problem, that's the idea. Okay. Let's skip down there to number 3, and it talks about that table. I'm not going to go through this one all together. I'm going to give you a little bit of time to work on practice here, but it says years on that. You don't want to use those as your X values. You don't want to use 1985 and 1991, 93, and that. You don't want to use those as your X values. What you usually want to do is set the lowest year to 0 and make so you would make the 1985 be 0, and then 91 would be, how far is that from 1985? So 86, 87, 88, 89, 90, 91. So this would be 6, this would be 8, this would be 11, 13, and 16. You done? Awesome. All right. You too. Text Miss Jones. Changed his name to Featherstone. Not Featherstone. All right. And then you would use those as your X values, and the Y values would stay the same. So anytime it's years like that, you want to set your lowest one to the 0 and go from there. Number four, the X values, I would use those numbers because they're miles, and that has some meaning in terms of that. So resetting your X values is a common practice with that. So keep that in mind. All right.